We are back, my favorite general chemistry class. Let's do this. We've got a few more examples of combination reactions that I want to go through. In our last video, we defined our redox reactions. I want to take that and apply it to a couple more examples. And I want to grow it just a little bit and include a decomposition. And we've got wrong pen. We've got decomposition and combination reactions in this one. And I kind of want to, let's start right where we picked up with our last video, our redox video. And let's try another one of these. Remember, every time we see a reaction now, it tells a whole story. In the first part of this unit, we told our math story. We calculated all of our moles. In the second part, we're going to kind of tell the story of what kind of reaction this is and what kind of process is happening. So let's take a look at this one. Let's write it out. We've got barium reacting with fluorine. That's one of our diatomics, don't forget. And then we're going to form barium fluoride. Okay, hold up. Let's go back to unit 2. How do we figure out how barium fluoride goes together and how that looks? Get your that came out terrible. Get your oxidation numbers. +2 for barium, -1 for fluorine. So how do we fix this? We need 2 of them. Okay. All right, perfect. Oh my gosh. Our next step is to balance, but can you believe this? Did I pick the wrong example or what? This is already balanced. But remember, in general, you can't trust me. They won't always be balanced. All right, so then what's number 3? We wrote out our formulas, and then we balanced. And then number 3, we've got to write out those oxidation numbers. So let's write out our oxidation numbers. If we're in the elemental form, there's 0. Now, why do we give a crap about oxidation numbers? Well, we're going to use them to figure out if this is a redox reaction. And remember, a redox reaction means that your oxidation numbers are changing from your reactants to your products. So in this case, they are. Let's take what we learned in the last video and let's do a quick spell out of what's happening. Let's start that half cell. Our barium and our fluorine are changing. Our barium is going from a 0 to a +2. Okay, what is that doing? Is that giving away electrons or is that taking electrons? That is losing electrons. All right, what about our fluorine then? We're going from 0 to a -1. We are gaining electrons. So this is definitely a redox reaction. We've got our 2 partners. We are gaining and losing electrons. The reason this reaction is happening, we have electrons flowing. That's awesome. Okay, then let's add to it. From our last video, what kind of reaction is this? Well, we've got an element on both of our reactants are elements, and we're making a compound in our product. So this is a formation reaction and a combination reaction. Now let's do some more examples of this. So we can have combination reactions that are not formation. That's totally possible. And we can also have combination reactions that aren't redox. So we have to literally go through the steps on each one of these just to see which ones apply. So as a reminder, your redox reaction, we have a change in those oxidation numbers. A formation reaction, we have only elemental forms on our reactant side, and we make a compound. And then what makes a combination? We have one product. That's it. We have a bunch of stuff combined to make one product. All right, let's go through a couple more of these reactions and just see what they are. I've got a few examples. All right, let's write this one out. Magnesium oxide. All right, let's pause for a second. How do we know how to draw that? Magnesium is a +2, -2 for oxygen. Reacts with carbon dioxide. Okay, and we're going to form magnesium carbonate. Well, what in the Sam heck is carbonate? You're going to definitely need your common anion sheet. I posted that whole packet on your Blackboard in case you didn't have it from class. It's under Blackboard Unit 3, just called Handouts. Your common anion sheet is on there. Our carbonate is a part of that. You would find that carbonate is CO3. And here's the fun part. All right, number 1, we just wrote out our formulas. Number 2, we need to take a second to balance it. We'll shut the front door, it's balanced. All right, number 3, let's have some fun with our oxidation numbers. All right, let's start with the carbon dioxide. Even though this is covalent, if we're trying to figure out if something's a redox, it is okay to look at oxidation numbers. Remember, strongest one is going to win. Your most electronegative element, carbon or oxygen, we start there. That's the one that's going to follow the rules. So our oxygen is more electronegative. That follows its rules of -2. And then by default, remember, we have to end up at 0. So carbon will be a +4. Now double check your periodic table. Is +4 an option for carbon? It should be. Okay. All right, let's do the same over here. Okay, now hang on a second. Magnesium carbonate, did we even put that together right? I'm going to spell this out bigger. We're about to write a bunch of things. All right, when you find carbonate on your common anion sheet, you find that the entire carbonate is a -2. Remember from Unit 2, this is what helped us draw carbonate, was that -2. And then it goes together awesome with our magnesium +2. Now for the purposes of redox, we're not done here. Hold your seats, it's going to get fun. So what do? Well, we have to figure out the oxidation number for the carbon and the oxygen within the carbonate. So we're going to follow the same rule. Which one is the more electronegative, carbon or oxygen? It's oxygen. Oxygen will follow its rules. Oh, that was just awful. Okay, -2. So then now what does this carbon have to be? All right, let's do a little bit of math. You've got a -2 on your oxygen, but you have 3 of them. And then in your overall oxidation state, you have to add up to a -2. So what does your carbon have to be? It's going to have to be a +4. And we saw already for carbon that that is an option. All right, so let me just highlight. All right, this -2, whatever is inside that bracket has to add up to that -2. So you've got to do just a little bit of math there to make sure those numbers are matching. But then in this overall process, well, son of a motherless goat, is this a redox? No, this is not a redox. Your oxidation numbers did not change. All right, is this a formation reaction? No, you've got compounds on this side. This is not a formation reaction. Is it a combination reaction? Yes, we have one product. This is a combination reaction. That's it. It's not redox and it's not a formation, but it is a combination reaction. Okay, wasn't that fun? Awesome. Let's do another one. Ooh, this is going to be sassy, I can just tell. All right, sulfur trioxide. Let's write that out. Sulfur trioxide reacts with water to form sulfuric acid. Now, naming our acids is coming in a video. It'll be a couple down on your Blackboard. It's coming. It's coming with our double displacement reactions. So I'll give this one away for free in this video, but then on your test, you'll need to know how to name that. So this will be sulfuric acid. Okay, I love it. All right, we just did number 1, we did our formulas. All right, number 2, we've got to balance it. Dang it, already balanced. Number 3, let's write out those oxidation numbers. All right, let's start with this sulfur trioxide. Between sulfur and oxygen, oxygen is more electronegative. So let's write the -2 for that. And we're going to start there. Now sulfur has to fit that, and we have to add up to 0. This has to be totally neutral. This is not sulfite. This is a neutral sulfur trioxide. There's no charge there. So this has to be a +6. Now pause and check your periodic table. Does that have a +6 as an option for sulfur? It does. Okay. All right, then what about water? We did that one in our last video. And then what about sulfuric acid? Let's write this one big. Now it's getting real in here. All right, how we're going to name this is coming in a later video, but we're going to recognize that this is our sulfate. If you find that on your common anions, you're going to notice that adds up to a -2. So this entire compound is neutral, so our hydrogens will be a +1. But now let's take a minute and actually figure out the sulfur and the oxygen. All right, our oxygen will follow the rules. It is the most electronegative. It's a -2, but you have 4 of them. That's a -8. Well, remember, overall, we have to equal a -2. That's what this whole, everything in this parentheses has to equal a -2. And your oxygen is already a -8. So what does sulfur have to be then? The only way to make that work is sulfur's got to be a +6. Okay? All right, so I am now looking at this. Is this a redox reaction? No. This is not a redox. Is this a formation reaction? Nope. Nope, you don't have single elements on your reactant side, but this is a combination reaction. It's a combination because we've got only one product. Okay. This is fun. I'm cruising. I hope you guys are having fun. Let's do another one. All right, let's tackle it. All right, calcium carbonate. Carbonate is one of our common anions. What's the charge on that carbonate? -2. So what's your charge on calcium? +2. Okay, we got lucky there. That evens out. All right, this one, it says it decomposes. That's a hint as to what kind of reaction it is. And it makes calcium oxide. All right, let's figure that out. -2 for oxygen. Calcium's a +2. Okay, so we put that together, right? And carbon dioxide. All right, we did our formulas. All right, we took a look at it. It is balanced. This is like the cheating video. Everything's balanced, right? And now number 3, let's fill in those oxidation numbers. All right, let's tackle that CO3. We're going to start with oxygen. It's the most electronegative, so it will be a -2. And then we did carbonate up just a little bit higher. And what did our carbon have to be? A +4. Okay. All right, let's double check our carbon dioxide then. Our oxygen is the most electronegative. It's going to be a -2. And now how do we add up to 0 there? What does carbon have to be? +4. Okay, I love it. All right, let's check this one. Is this a redox? Nope. Look at your oxidation numbers. Not a single one of them has changed. That is not a redox. Is it a formation reaction? Nope. In fact, you don't have elements on this side. Is this a combination reaction? No. You have more than one product. So what in the Sam heck is this? This is a decomposition. I like to group it. I like to group this with combination because they are the opposite of each other. And they often work in reverse of the other one. So you could also take calcium oxide and carbon dioxide and go backwards and make calcium carbonate. So they are often the reverse of each other. How do you know if something's a decomposition? Here's my shortcut. We have one reactant. That's it. That one reactant is going to decompose and fall apart and make several products. So that is what a decomposition is. They can be redox. They cannot be redox. It just depends. In this case, it is a decomposition and it is not a redox. So remember, combination and decomposition, they kind of go hand in hand. They're the opposite of each other. Combination, one